Okay, so what does the first question say? It says in the figure, in the given figure, you have DE parallel to BC. So there's a triangle and you have DE which is parallel to BC. And AD, AE, BD, and CE are given in terms of a variable X and you have to find X. So this is a direct application of the basic proportionality theorem or the Thales theorem. And you take 2 minutes to try and attempt this question and later discuss it afterwards. So you take an attempt at this question, okay? Just watch out. It's given that DE is parallel to BC, so we can directly apply the Thales theorem to it. And you can write it, the Thales theorem. So you have AD by BD is equal to AE by EC. And this is what you're going to use. You're going to form an equation. It's in a variable X, so you just need one equation. And once you get the equation, you'll be able to get the answer. Okay, so you just take 2 minutes and try to solve this question. Okay, be careful with your calculations because it's an easy question, but the only problem that you can face here in this question is when it comes to calculations, you might just do an error there. So you just have to be careful with the calculation. And when you get the values of X, make sure that you check whether the values that you've got would actually satisfy or whether they are possible or not. Okay, so this is one thing that you have to take care of. Whenever in the denominator you have an expression in X, you must always verify the values at the end. Okay, 1 minute is passed, last minute. Okay, and then I'll try to solve it out and you check whether your answer comes same as mine or not. I hope you guys got the equation right till here. Okay, and then you simply open the brackets and solve it. Okay, so let's see what it will be. It will be 4x into 5x is 20x square minus 12 minus 15, so it will be minus 27x plus 9, and on the right hand side you have 24x square minus 8 and minus 21 is minus 29x plus 7, or you take it, you form the standard equation, so you have 4x square minus 2x minus 2 equal to 0, or 2x square, you take 2 common, so you get this is the final equation. And the values of x will be minus b plus minus root over b square plus 4ac by 2a, which is 1 plus minus 3 by 2, which is 1 and minus half. This over here I use the quadratic formula. In case you have not yet studied the quadratic equations, you can also do it by splitting the middle term. You split the middle term by doing what? Minus 2x here and plus x over here. Minus 1 is equal to 0. So you have 2x common, x minus 1 plus 1 into x minus 1 is equal to 0. So you have two factors, 2x plus 1 and x minus 1 equal to 0. So you get x is equal to minus half or x is equal to 1, which is what you will get when you use the quadratic formula also. Now you got two values of x, but let's see if x is equal to minus half is possible or not. Now AD is equal to 4x minus 3. If you put x is equal to minus half, you are going to get minus 5 as the answer. And AD, which is the length of a side, cannot be negative. Hence x equal to minus half needs to be rejected. And the only possible value of x in this case is going to be 1, because it satisfies all of them get a legal value. So all of them will be positive if x is equal to 1. Hence, the possible value of x comes out to be 1. So everybody who got two answers, you have to be careful. I said that when you get two answers and you have an expression in the denominator, an algebraic expression in the denominator where there is the variable is also there, you need to put the values that you get, final values that you get, to check whether they satisfy or not. Okay, so x is equal to 1. Whoever has got this answer has done it correctly. All right. Now let's move to the second question. It says there is a figure. Again, this is an NCERT problem, and it says in the given figure, if LM is parallel to CB, so you have LM parallel to CB and you have LN parallel to CD. The D goes missing in the figure here. I'll just write it down. You have to prove AM by AN is equal, AM by AB is equal to AN by AD. So again, I will give you 2 minutes to do this question, and then we'll try to solve it ourselves. Okay, please attempt. Go ahead. This is a direct application of the basic proportionality theorem. I can see two triangles, and I'll make use of the two triangles and also the basic proportionality theorem to arrive at the result that we are looking at. Okay, so that's a hint, and try to solve it out. I'll be posting the assignments related to this particular concept as well. So take a shot at that. Okay, do not keep it in abeyance that the school is not teaching this chapter or whatever. You must attempt it now that it's fresh in your mind. How many of you started with this? If you started with this, then you are in the right direction. In triangle, okay, so concentrate on the screen now. We have two triangles, a triangle ABC and the triangle ACD. Okay, in triangle ABC, you have LM parallel to BC, which is given. Therefore, AL by LC is equal to AM by BM by basic proportionality theorem. In triangle ACD, again it's given that LN is parallel to CD. Therefore, AL by LC is equal to AN by DN. Again by basic proportionality. From 1 and 2, the left hand sides are equal. So we have AM by MB is equal to AN by DN. And this is what you have to prove. So it was a very easy question to attempt. It shouldn't have taken 2 minutes. Okay. So it takes time to write. So I'll give you, if you solve it in 2 minutes. It's a very short question. Okay. I hope nobody gets confused in this one. Now the third question for you. This one is a bit trickier question. So it's given that ABCD is a trapezium in which AB is parallel to CD and its diagonals intersect each other at the point O, and we have to prove that OA by OB or AO by BO is equal to CO by D. Take a shot at it. I'll give you 3 minutes to this question. Again, the hint is already there in the figure. You have EF. They have drawn a line EF which is not given in the question. You have to make use of that to solve this question. So take 2 minutes and try to solve this question, and then we will discuss. Okay? Please go ahead. Note that ABCD is a trapezium. So in trapezium, the opposite sides, one of the pair of opposite sides is parallel. So even if it was not given, you could have guessed that CD and AB are parallel since ABCD is a trapezium. Or if it was not given that ABCD is a trapezium, but it's given that in a quadrilateral AB is parallel to CD, then you can infer that that given quadrilateral would be a trapezium. And the trapezium becomes an isosceles trapezium if the other two sides are equal. So if AD equal to CB and CD parallel to AB, then this particular trapezium would be called an isosceles trapezium. This is just for your extra knowledge. Okay, so let's attempt this. What we do here is we construct or we join or we construct, not join, we construct a line OE, a line from point O to the side AD parallel to A. Once you do this, okay, once you do this in triangle ADB, what do you see? OE is parallel to AB by construction. Okay. So if OE parallel to AB, therefore we have DE by AE equal to OD by O by basic proportionality theorem. Okay, this is correct. In triangle ADB, OE parallel to OB, so DE by AE is equal to OD by OB. Okay, now OE is parallel to AB by construction, right? By construction. And AB parallel to CD is given. So what do we have? OE parallel to AB and AB parallel to CD. So if A is parallel to B and B is parallel to C, so A will be parallel to C from Euclid's postulates, if you remember. Okay. So one thing, you have OE parallel to CD is what you get. OE is parallel to CD. Now if OE is parallel to CD, therefore in triangle ADC, what do you observe? You observe that OA by OC equal to AE by D, again by basic proportionality theorem. So this is equation number 2. Now what do you have in equation 1 and 2? What we see here is OC by OA will become DE by A. I take the reciprocal. Okay. Now from 1, instead of DE by AE, what can I write? I can write OD by OB. Right? This from OD by OB. I'm sorry. This is from 1. Okay. So we have We can leave out the middle part, so we have OD by OB. Okay, this is from 1 and 2. Alright, so 1 and 2 we can straight away say here that from 1 and 2 OC by OA is equal to OD by OB. And what did we have to prove? OA by OB. So I'll cross multiply. So I'll not take this OB, I'll keep it here. I'll take OA to the other side and OD to this side. So we have OC by OD equal to OA by OB, which is what we have to. Okay, this you can do. You can take this to the other side and this to this side. So you have OC by OD, and on the right hand side you have OA by OB. OA and OB, this AO is actually OA and OB, BO is OB. So this is what you have to prove. So what we see here in this question will be used in the next question that you are going to solve. So in a trapezium, the diagonals intersecting at point O, then AO by OB will always be equal to OC by OD. So you have in a trapezium OA by OB is equal to OC by OD. Or you can say OA by OC is equal to OB by BD, which is what we got here. Okay, so you can use either of the two. OA by OC is equal to OB by OD is what you get here. Okay, you can rearrange and you get the same thing. Fine. Now this question. This question makes use of practice question number 3. Okay. So you just take a look at the practice question 3 because you are going to make use of it in the question number 4. Okay. So now you solve it. I'll give you 2 minutes to solve this. You make use of the result that you got in the last question, or you can just try to reprove it again so that you get a hang of what we did in the last question, and then you solve the quadratic equation or whatever equation that we get here. Okay, so take 2 minutes to solve that. I've written the result from the last question here, so you can make use of it. Okay, but you must remember what it is. So in a trapezium, the diagonals intersecting at point O, so OA by OB will be equal to OC by OD. This is what we got in the last question. You can use it. Okay. I'm also solving on my own and you also solve, and maybe we can tally our answers. Okay. So you have 3x minus 19. Try to solve it yourself. Okay. Don't keep staring at the screen and copying it. Okay. This is for practice, so you must make use of it. Did you get 8 and 11 as the answer? If you got 8 and 11 as the answer, then it's correct. Just have a look if you did any calculation mistake, because it was a simple quadratic equation that you had to solve. The result we used from the last question, I cross multiplied, I got an equation. I factorized it, I split the middle term and found out the two factors, and then I equated it equal to 0, and I got x equal to 8 and x equal to 11. Okay, the equation that I got was x square minus 19x plus 88 is equal to 0. Just have a look whether you got this as well or not. Okay, so just give you a moment to copy it in case you were not able to solve it. Okay, or you don't need to copy it. This video would already be available in your list of resources, so you can always get back to it. So you just have a look. 8 and 11 is going to be the answer. If you didn't get it, just revisit your solution if you followed the same steps. Okay, now next question. The next question says, if there are three or more parallel lines cut by two transversals, prove that the intercepted segments of the two transversals are proportional. I'll solve this question for you, okay? Because I think we are nearing the end of the lecture, and probably by now not everybody would be following it as attentively. So what it says is, for three lines or three parallel lines or more, so I've taken three parallel lines, there are two transversals, and it says that we have to prove that BD by DF will be equal to AC by C. Okay, so this is what we have to. Now you draw a line. Okay, you join B and so it becomes like a third transversal. Why did I do it? To form a triangle. Okay, now we have AB parallel to DP parallel to EF. It is given, and these two are transversals. M1 and M2 are transversals. So in triangle BFE, we have BD by DF equal to BP by PE by BPT. We take this triangle BFE. This triangle BD by DF will be equal to BP by PE by basic proportionality theorem. And in triangle BAE, what do you have? You have CP. This part is going to be parallel to AB, right? CD is parallel to AB, so CP is also part of AB. So in triangle BAE, you have CE by AC equal to PE by BP. You have CE by AC equal to PE by BP by basic proportionality theorem. Now, you can say AC by CE equal to BP by PE. Call this 2, okay? So from 1 and 2, we have BD by DF equal to AC by CE. This is what we have to prove. Okay? Proof is done this way. So you have three or more parallel lines. We have taken three. You can also do it with four lines. Okay? So you have three or more parallel lines, and what does it say? It says that the transversals cut equal intercept. So you have the ratio in which they intercept is same. So BD by DEF is equal to AC by CE is what you have to prove. You draw a line joining B and D, so extreme, the diagonally opposite points of these two. And then in the triangle BFE, you have BD by DEF is equal to BP by PE by basic proportionality theorem. And in triangle ABE, you have CE by AC is equal to PE by PB. You make use of these two equations to prove that BD by DF will be equal to AC by C. Okay. Uh, So with this, we come to the end of the practice questions. More questions will be available to you in the assignment segment, and you attempt those assignments, and then maybe we can discuss the any of the doubt areas that you might be having. So I hope it was a very productive class that we had. And in case you found it too taxing, just go and relax a bit, and probably in the next class come back fresh, because we're going to take up a lot of more proofs, and it will be pertaining to the similarity of triangles. But I'll try to make it shorter, and I'll try to give some breathers for you in this particular chapter, because it's really a tough one to understand. At least from my side, I always found this chapter very tough to understand. So I'll give you that time, I'll give you that benefit of doubt as well, and keep practicing, because this is what will make you perfect in geometry. Okay, have a good day.